Alright. We'll start a little bit of Kubernetes and then we'll add something to it. Then we'll move on to AWS. Alright. Let's redo the quick recollection that we normally do. All Kubernetes keywords. Monoliths, microservices, orchestration, self-healing, auto-scaling, containers, very good, pods, nodes, master, worker, then your primitives. Right. Primitives, you have 6 HCD, Cube API, scheduler, always in the same order. Controller manager. These 4 are on your master. Then kubelet, kube proxy. Then the container runtime interface. kubectl. Oh, yes. Deployment. Very good. Service. Ingress. And ingress controller. These 2 are separate. Service. What's the internal service? Cluster IP. External? Load balance. There is another one called node port. We will talk about it. Then, what did we add yesterday? Namespace, correct? API object, very good. So I'll write these things here. Namespace, API objects, context, very good. Then we talked about kubectl and the YAML file. What are the 4 things in a YAML file? API version, kind, metadata, specs. That's perfect. All right. That's what we have seen so far. And we also seen 4 or 5 types of common commands that you normally get. All right. The life cycle of all these objects. What are those 4 or 5? You create something, then you delete it. You edit it in the meantime. You need to get what you are trying to edit. All right. Remember these 4. We'll be working on many of the commands using these 4. All right. That's it. We will add as we go on. Today, we're going to talk about some important things. Daemonsets. We also have to start the hands-on on this one. Probably we'll be starting it tomorrow. Daemonsets. Then persistence volumes. Persistence, this is called PV, popular. Persistence volume climb. All right. Then storage class. I'm introducing all these words. One of these words. We keep repeating these words again and again. Storage class. stateful set or stateful application. So you have stateful application, persistence volume client, storage class. Before that, daemon sets. All right. Daemon sets. These daemon sets are related to replication sets. Replication sets we already know. What is a replication set? Let's get back to our original structure. Master, worker 1, worker 2, isn't it? So you have HCD, API, scheduler, controller manager, CRI, kubelet, kubeproxy. So kubelet, kubeproxy, kubelet, kubeproxy, CRI. All right. Now let's say you did a deployment on this thing. A deployment is a logical group of pods, isn't it? Let's say on these two worker nodes, you did a deployment. Let's say the number of replicas you said is, let's say 3. 1 in worker 1, 2 in worker 2. Who decides that thing? Scheduler. Perfect. So the replica set consists of 3 replicas in this case. But the number of replicas on each worker node is decided by the scheduler, and it need not be same. That's a keyword. It need not be same. Depending on the capacity of the worker node, a scheduler can choose to put more number of pods on one worker node and less number on a different worker node. Correct? Now, in case of daemon sets, now that is replica set. So a replica set is a group of pods spread across the worker nodes, all right, irregularly. Whereas the daemon set is spread across all nodes, one on each. That's definition. Which means if a cluster has 2 nodes, a daemon set will have 1 pod on each node. So 1 on each. Guaranteed. The daemon sets are usually monitoring tools, agents. Let's say you want to monitor a cluster, all right? You install a pod on each worker node. All the job that it is doing is just monitoring the node. It's extracting data from that node. So CPU, RAM, available storage, that's it. Basic data it's collecting. And it will send it to some other place that we decide. So you need just 1 pod over there. You don't really need too many. So such replica sets, which have only 1 on each node, are called daemon sets. And the most common uses of daemon sets are monitoring tools. Let's introduce a new word here. The most popular monitoring tool is Prometheus for Kubernetes. Prometheus, that's how it's pronounced. Prometheus. There is a movie on this name. Prometheus. Prometheus is the name of a Greek god. So when we deploy this Prometheus monitoring tool to our Kubernetes cluster, our expectation is that we are able to monitor all our pods. This Prometheus tool itself is deployed as a Kubernetes application. So what happens here is there will be 1 pod here then there will be one pod here. If you have another worker node, there will be one pod on that one also. So what you have is a daemon set of Prometheus app will be deployed to your Kubernetes cluster. So when somebody says you're deploying a daemon set, it means you have one pod on each node. That's your definition. A daemon set is one pod on each node. Let's rephrase this one. One pod on each node. That's a daemon set. Now that we talked about Prometheus, there is an associated tool also along with it. Prometheus only collects the data. It's not really good at showing the data to us. Now, collecting the data without actually seeing is useless for us. We want to see the data. That's the very reason we are collecting, right? Now, Prometheus has a dashboard. It can show to us, but that's not really powerful. So always we use an external dashboard called Grafana. Grafana. So you will always see this combination. Prometheus is the server which collects what we call metrics. It collects the metrics, and the metrics are easily visible on Grafana dashboards. Prometheus itself has a dashboard, but it's not really powerful. It's not really user friendly. So everybody installs Prometheus to collect the metrics, and whatever the metrics that it is collecting can be seen or visible on usually Grafana dashboard. So when we do this monitoring tool deployment, we do a Prometheus deployment. We also do a Grafana deployment. The purpose of Prometheus is to collect the metrics, and the purpose of Grafana is to show those metrics in nice dashboards. We will see those things also. Right? So that's your replica sets, daemon sets. What's the major difference? The difference between replica set and a daemon set. In a daemon set, each node has a single pod, only one pod. Whereas replica set, there is no such condition. You may have a pod or you may not have a pod, all right? Or you have uneven number of pods. So that's your daemon set. Now let's come back here. Let's first try to understand what is a stateful application versus what is a stateless application. Forget the application part. What is stateful and stateless? What is stateless? Forget stateful also. Forget technology, general word. Stateless, what does that mean?
It's not in a proper state. Phase.
That is improper state. Stateless is not having any state at all. Improper state is still a state.
Not confined to a particular state.
Okay, can you give an example? The general problem, the normal stateless thing that we learn is in science. Components or products do not have any state, solid, liquid, or your gaseous state. One of these three states are common. Now, if a substance does not have any of these states, it does not have any state. That's one way. Another way, another word usually stateless is you do not belong to any country. You are not a national of any country. You are stateless. Now, usually this happens when countries disintegrate, you dissolve, like that. All right. Now you have a state too. You're an Indian. all right, or you are another citizen of another country. Let's say you are not a citizen of any country, you are stateless. The same thing, you seen the movie Terminal, Tom Hanks, Terminal. He lands in an airport, all right, he's traveling to US. He lands in a New York airport, I think. The moment he lands, his country, Kazakhstan, is disintegrated. Means it doesn't exist anymore. Now the airport guy says, you do not belong to any country, which means we don't know what to do with you. Because every country allows other country citizens based on how their relationships are with others. Right? We don't allow certain individuals, they don't allow us into their country. Or US has a restricted list of countries who they want to scrutinize more. Right? So if you don't belong to a country, the immigration officer does not know what to do with you. He stays in the airport for almost, I think, 2, 3 months. So that's the movie. It's a nice movie. Watch it. Now let's get back here. A stateful versus a stateless application. Take an example of e-commerce. Our popular Amazon. When you're browsing through the Amazon list of products that you want to purchase, you select, let's say something you like. You like the nice laptop or a mobile. You select it. It goes into your cart, right? Then you keep browsing. You are not purchasing it yet. You want to make a big list of items. Then finally you want to purchase it, the checkout thing. Now while you are doing this browsing, once in a while, whenever you like something, you select that I like this and it goes into cart. Now let's say you close the session, browser session. You came back after an hour or so. If you open Amazon again, will you see all the selected list or you won't?
If it is logged in, then yes.
If it is logged in, yes. If it is not logged in, probably you'll lose it. That's one thing. Means when you close it and when you come back. Now let's consider a minimal version of this operation. You, you are on one page, you selected something, it is visible on the cart, even when you are not logged in. Right? Then you clicked on some other product description. It moved to another product. All right, you are not on the previous page anymore. When you are on the new product page, means you navigated by clicking on that page, will the state of the previous product still be available? It should be. That's what the expected behavior of the application is. Will all the applications behave like that? You've been to a lot of websites, right? So e-commerce applications usually behave like that. Means a customer can log into a website, select like, click, 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 and you can keep on browsing. It will store all the likes that you've done. But the same thing may not be true for all applications. If you are just browsing through some random website, it won't store anything. When you click on a specific link, your previous thing is gone. It does not remember it. So there are certain applications which will remember what you have done. At least in that particular session we are talking. We did not close everything. Our session is open, means your browser session is open. You're just navigating through the links, one link after the other. Right? This is, let's say, this is the same website. These are 3 pages. If it is the e-commerce site, you liked something here, you go here. On this page also, you will still see the details of previous one. So the application has taken the state to the next navigation. Again, same thing. On other applications, it probably will not remember. Once you click on a HTML link, it goes here. And the only way you can come back here is by clicking the back button. The session itself does not remember it. It's the browser that remembers it using the browser history. All right? Here, whereas a session remembers it. Now that's a major difference. Any application that needs the state to pass on to the next operation or that stores the state is usually a stateful application. The most common example is all your e-commerce. And the state that you are carrying forward is the cart. The cart state is what you are carrying forward, right? This is usually implemented using a cookie or a bean. A lot of variations are there. That's something that the developer will take care of. How to store the state from one pane to next pane. But any application that stores the state or needs to store the state is usually a stateful application. Now, when you want to store something permanently, you need a permanent storage. And the only permanent storage that we know is hard disk, isn't it? Anything else is transient. Temporarily, probably you have that information. At the moment you close it, it goes away usually. Right? Agreed? RAM, for example, is it permanent or temporary? It's temporary. The moment you switch off your laptop, all the things in your RAM are gone. Whereas hard disk is permanent. Now you have both types of hard disk. Your HDDs, which are the old styles, SSDs nowadays. Alright? Both are permanent storages. So let's see. So if you want to store, or if an application wants to store a state while it is running, it needs some kind of storage. That's your central point for this discussion. Now let's say you have an application deployed to Kubernetes which wants to store its state. Let's take the example of WordPress. WordPress is a blog, just like your Tumblr. You're familiar with Tumblr? Or let's say Instagram. Instagram is also a blog. You're familiar with Instagram, pretty sure. All right. So what Instagram has is you post an image, it stores it somewhere. All right. So there's an interface, the front end, and then your image gets uploaded. The image gets stored in the back end somewhere. Now, if you are developing that thing on a Kubernetes style thing, so you will need two types of containers. One is your front end, the container. In this front end, you have Apache. That's where the interface pages are usually put in. Now, WordPress is in Apache, then MySQL, PHP. It's called LAMP package on Linux usually. So LAMP, Linux, Apache, MySQL, PHP. Right? It's called a LAMP package. If it is on a Windows, it's usually called an XAMP package. So that's just the infrastructure. So what we are interested in here is you have an Apache server to which you are going to deploy the front end. Then you have a MySQL database where your data is stored. So here, a WordPress application has two containers. One container Apache, other container MySQL. Isn't it? So the Apache has to contact MySQL and store its data. All right. This is a stateful application. Now, why does WordPress or any other application need to store it is, that's the need of the application. If you are an e-commerce application, you need the state to be stored. Right? By the way, WordPress itself can work as an e-commerce application also. This can work. Means this also requires some stateful properties. Now let's come back here. So you have an Apache and MySQL. You want to store it. Now when MySQL database is deployed, it requires a storage, isn't it? This requires a storage because everything that MySQL stores in its database, it wants it permanently stored. It's not like when this pod goes off, you lose the data. Not like that. So if MySQL wants a storage, obviously it has to get it from somewhere. All right, let's say there is a hard disk here. What it can do is this pod or the container can take some hard disk space from the hard disk available on the node. All right, so that hard disk is called a persistence volume. So persistence volume is basically a hard disk. Now this hard disk need not be always on the node. It can be local or it can be cloud. So you have a stateful application which needs to store the data permanently. And the permanent storage is usually a hard disk or what we call a persistence volume. Clear about these two words? This is also a very common question in interviews because this is a very common usage. Everything requires a database. Everything requires a hard disk. Therefore, stateful applications are very common now. So a stateful application requires a storage, what we call a persistence volume. Now the next two things are about how the stateful application gets this persistence volume. That's it. Stateful application wants persistence volume. And to get this done, these two are used. These two are middlemen. All right. Now let's see what it has. So this container wants the persistence volume. All right. Now instead of a local volume, I'm going to make it a cloud one. Let's say you purchased some storage on Amazon, AWS. So let's call it AWS storage. What are the three types of storages we have? S3, EBS, EFS. All right, one of these three things depending on what kind of data you are storing. If you are storing only database, you need EBS. If you are storing just images, you will require S3. EFS is same as EBS but available globally kind of. Now this guy wants this. Now your persistence volume is this cloud storage. All right. Now because this is cloud storage, anybody can access it, isn't it? All nodes can access it. It's just cloud. If you have internet, you can access it kind of. All right. Now this container wants this persistence volume. The container is running a stateful application. All right. Now the way it executes it is when you are creating a container, you will give what is called a climb. You will attach a climb. So attach a PV climb to container. Let's see what is a climb. Let's try to understand. What is a climb in general? Insurance claim, that's very good. So when you say insurance claim, you claim the insurance. What does that mean?
You spend money and you lost.
We are asking the insurance money to be paid back to us, all right? You paid all the premiums, all right? Then you are going ahead and you are claiming your insurance. It could be, let's say, your bike insurance or a car insurance, life insurance, anything. Let's say you have a car, the car is damaged, you have already paid the premium. Now you go to the company and you claim it. Your claiming is basically you're saying, give me back what I want. So a claim is usually a right. Can you correlate that? So a claim, when you're saying you're claiming your money, you are taking back your right. Very simple thing. Now here, this container or pod has a climb, means it can climb. What it can climb? Storage. But it should have the climb. And somebody should give you an insurance so that you can claim it, either yourself or your father or somebody. All right. In this case, when we are deploying the application, we attach this claim to the container or pod, which means this container pod has a claim that it can take back from somebody. So a persistence volume claim is a right or a property given to a pod that it can use and get the persistence volume. So if you want a volume, you should have a claim. So stateful applications, when are deployed, because they need persistence volume, they are usually attached with a claim. If the container does not have the claim, it cannot get the persistence volume. Clear? So a container or a pod needs a claim always if it is looking for storage or persistence volume. So a persistence volume is the storage and the claim is a property or a right attached to a pod or container. Now obviously when this container or pod goes to the persistence volume with the claim, the persistence volume is just a storage. It does not know what to do. The only thing it knows is how to store data. That's it. But somebody has to allocate that persistence volume to the container. Means the execution has to be done. All right. That allocation is done by what we call the storage class. This is the object that executes the claim and allocates the persistence volume. So he is the manager kind of thing, the middleman, the storage class that does all the things. So the pod or the container says, okay, I have a claim for persistence volume. And who it says to? To the storage class. Then storage class verifies the claim. Okay, everything seems in order. You can get your persistence volume. Then it goes to the storage provider or the persistence volume and allocates whatever is in the claim. Let's say the claim says you are eligible to get 2 GB of storage. So the storage class allocates 2 GB from the persistence volume to this container or pod. So storage class is the middleman or the object that executes the claim. Container claims the claim. So container claims it through the storage class. Storage class goes to the persistence volume, executes the claim, and gives that persistence volume to the pod or container. Now this whole terminology is really important. So there are 3 or 4 sentences here. Let's write down those sentences so that they stick to your mind. So you attach a claim to a pod during deployment. This is PV claim, persistence volume claim. After you attach it, a pod will invoke storage class. Invoke is the next keyword. Invoking basically asking the storage class, so I have a claim, go get me my persistence volume. All right. Then 3, storage class allocates persistence volume to the pod. That's it. These are your 3 sentences that you should remember. And when you have all these things in stateful applications, what is a stateful application? Any application that needs to store its state permanently. Any database is a stateful application. All databases want to store the data permanently. Some front-end applications are also stateful applications. They want to store session information, that kind of thing. So a pod uses its PV climb through storage class to get the PV. That's your single sentence. Let's put it that way. A pod uses a PV climb through a storage class to get PV. That's your single sentence that says everything about what we discussed. Write it down in your notes, mark it with stars. Keep your running notes really dirty, otherwise you won't remember. It has to be unique to you. When you recollect or when you refer back to it, it should actually refer to something that is happening here, all right? Something that is happening on that particular day. All right? Let's write down those additional things here so that we can start working on those things. So we have daemonsets. That's one thing. Then we have added 4 new items. Stateful applications, persistence volumes, persistence volume climbs, storage class. We're almost done. There are some 3 or 4 more concepts that we will talk tomorrow, and we'll be working on these activities from tomorrow onwards. All right, any questions in any of those things? Yes.
Yeah, that we are using that persistence value
Right.
Without claim.
Okay.
In that we are using local.
Okay.
Storing in local.
Local. Oh, some directory.
For cloud only we are using claim.
No, for anything you need a climb. The type of climb will say that where your persistence volume is. So persistence volume is just a path. The path could be a local directory path or it can be a cloud URL also. It does not really matter. So persistence, if any pod needs storage, it has to have a persistence climb. Whether it's local or cloud, doesn't really matter. That's how the abstraction is. Means the pods do not really know anything about how the storage is. They don't want to know. All that they know is, I have a climb, get me the climb. It could be a local storage or it could be a cloud storage. That's where the beauty of the whole Kubernetes thing is. You don't have to worry where the storage is. You can be running a Kubernetes cluster here on your laptop while your whole storage is on AWS cloud. You just have a climb which will refer to your persistence volume which is on the cloud. So any storage, local, cloud requires the same process. It's always same. Any other questions? Good. We'll move to AWS. We were talking 6 categories of things on the cloud. Let's write down those 6 things. What's the first one? IAM, Identity Access Management. Then compute. What are the 3 compute things? EC2, Lambda, Lightsail. Then we were talking about storage. 3 things again. S3, EBS, EFS. Then 4th, networking. We're going to see this today. Then 5th one, what is that one? Monitoring. Correct. Under monitoring, we have CloudWatch and CloudTrail. Then finally, we have automation, infrastructure as code, AWS CLI, the command line interface. Then you have SDK. SDK is your Python Boto 3 package. IAC is your cloud formation. Another popular IAC, anybody knows this thing? Not from AWS, but from outside, is Terraform. Terraform is more popular than cloud formation. Right? So a general recommendation is learn a little bit of cloud formation, then move on to Terraform and learn everything on Terraform. That's a general recommendation. Now let's get back. We want to add one more here, 7th category, a database. It should come in storage itself, but we want to change it a little bit. So you have RDS and then Aurora. We'll talk about those 2 things also. Now let's add some more things into this thing. The first thing in IAM, we'll go a little bit. Users, groups, roles, policies, and access using username, password, certificates. We're going to see this thing. Then we're going to touch upon network, VPC, internet gateway, NACLs, subnets, ingress, egress. Always remember in clusters. Let's look at all these things as a group. What's a user in general? This you will know already. You log into Gmail, you give your username password. Right? So that username that you are creating or giving is usually user. These are also called principals or principal. They're not exactly same, but for now it'll work. Principal, or you can call it ID, anything. All these are users. Now let's forget the groups. Come to roles. What's a role? A role. We'll talk groups in a moment. User is a user or some ID that you use to log into an application. Your Gmail, Facebook, anything. Right? What is a role? You play a role, which means a task you perform. Okay. Any other example?
For a teacher, we have students.
Okay, teacher student role. Okay, that's good.
What we do, what not.
What to do, what not to do. The authorization. Okay, very good. Okay, so you have a general idea of a role. So role is kind of a designation, you can say it, and simple put it in words. So a user logs in and performs certain actions based on what the role of the user is. It applies to real people and also it applies to common usernames that we use to log into applications. Right? So let's say you're working or you walk into your office, you perform a role. You're probably a software engineer, or you're a manager, or you're a team lead, or you're a CEO of the company. That's your role. Your role, the moment you say a role, it has an associated set of authorizations associated with it. Means you can do these things, you cannot do these things. That's what role is all about, isn't it? You walk into your office, if your role is a senior software engineer, there are things that you can do, there are things that you cannot do. So roles are usually associated with authorization. So based on what you are authorized to do, you will give it a name. Like you said, student, trainer. This is role 1, this is role 2. Let's call it RS. We're just giving it a name. RS is a role that every student will have. RT is a role every trainer will have. Now, once you have a role, you have a set of things. All right, authorized to do what? You are authorized to sit in a class, you are authorized to operate everything in this room, you are authorized to ask for all the content, you are authorized to ask questions, you are authorized to interact with all the staff, everything. This is all authorization. Now, you are also not authorized to anything that is not in this list, you are not authorized. So, authorization is an explicit list. All right, you are allowed to do only these things. If it is not in here, very likely that you cannot do it. All right. Then a trainer has certain authorizations. All right. Use all resources of Office, ask for content, ask for prints, ask for salary, all that stuff. So every role has an associated set of authorized activities that role can perform. So what normally happens is we log in with a user, we assume a role and perform everything that the role is authorized to perform. All right. Now, when you're authorized to perform, let's look at the next thing, a policy. A policy is usually attached after the role. Now, let's say here, student is the user. Let's say ABC is one student. All right. They assumed a role RS. This role allows to perform all these operations. All right. Now, looking at one of these things, as a sit, we are saying, all right. Now, you can sit anywhere. Let's say one of these benches is broken, or chairs is broken. All right. We say, don't sit here. Don't sit on this chair. So, this don't sit on this chair is a policy attached to one of the objects. So, even though you are authorized, the policy here denies using this object for whatever reasons. In this case, it's broken. So, what's happening here is you have a role, you are authorized to do certain activity by that role, but whatever object you are performing that authorization on is denying that activity based on a policy. So a policy is a condition usually set on the object, whether somebody can use it or not. So usually, this is how it is. The policy of the chair says anybody who has a student role can use it. So what we have here is a mapping. So role 1, role 2, role 3. Let's say role 1 is student role. Role 2 is teacher role. Role 3 is staff. The policy of the chair has these three roles listed on it. It says if anybody has either R1 or R2 or R3 role. R1 we are saying if anybody is a student or anybody is a trainer or anybody is a staff, they can use the chair. So the policy of this object is just listing a certain roles. And when you are logging in as a user and assuming a role and you try to do something, all right, that you are authorized to, the object simply checks its policy. And the current role that you are assumed, if it is part of that policy list, you are allowed to operate on it. Now, this process works for all softwares. Wherever you have username, password kind of thing, wherever you are trying to log in and do something, you will see that. Now, you see this popular error, you do not have permission to do this thing, or you are not allowed to click on this, or you are not allowed to modify this property. Please contact the administrator. All these things are violations of policies. The role that you are operating at that moment is not listed in the policy of the object that you are working on. Very simple. So what we have is a user is a general ID that you'll use to log into your software. This is authentication. You are authenticated. Once you log in, you can perform certain things, you cannot perform certain things. What you can and what you cannot is the authorization. Everybody has to log in, like you have to walk in. Everybody has to walk in into this office. Means everybody needs to be authorized. Means if somebody is here, they are already authorized in the front office. You are either a student or a trainer or a staff. You are coming with one of these IDs. If you are not one of these, your authorization fails. They'll stop you over there. All right? Now, everybody gets authorization. After you are authenticated. After you are authenticated, what you can do in this office is based on what you are authorized to do or what your role is. If your role is staff, you go on and do something else. If you are a trainer, you do something else. If you are a student, you do something else. All right? Now, while you are doing these things, the policy of each of the objects that you are working on, again, allows or denies that particular role. All right? You can be a staff. Let's say you are assuming a role of staff here. All right? Role staff. Now you are authorized to walk in and check stuff. One of the files in a cabinet says only a center manager can open this file. So what is happening over there is that policy of that file only lists center manager as the authorized person to operate it. So you have rules which will define it, and then the second level you have policy which will list the roles. All right? So let's try to summarize everything. So you have authentication, then you have authorization. Authentication is usually login. Authorization is perform action.
In policy, who will restrict, sir?
We have to define the policy.
Define, okay. Who will restrict what to do, what
Okay,
not
there
to
is
do?
an authorization module here. Every time you click on something, it goes through an authorization module. The authorization module either allows or denies your request. It happens really quickly. Let's say you are clicking on a link which you are not allowed to modify. All right. Now, when you click on it, it goes through an authorization module which is part of that software. All right. That authorization module decides whether your role that you currently are logged in has the permission to modify or operate this object or not. And it tells allow or deny. If it allows, the page opens up. If it denies, the error message opens up. So every request that you are doing, everything that you are doing, always goes through the authorization module. So authorization module keeps on working. That's a good question. Whereas authentication module works only when you log in. All right, after you logged in, authentication module has not much work. Whereas authorization module is continuously operating whenever you are clicking on anything at all. All right, now the performing action is based on roles, and roles are defined in policy. So a policy has a list of roles. Authorization roles is a list of allowed actions. That's roles. Now these concepts are important. All softwares have same concepts. So once you understand these 4 or 5 terminology, everything is same. Authentication is the login. Authorization is performing an action. A performing action or authorizations are usually controlled by roles. The role simply lists out what you are allowed to do. And this role is also attached to a policy object. A policy is simply a list of allowed roles. All right. Any questions so far? Now, a group is pretty simple. A bunch of users is a group. It has no other meaning. The reason why we use groups is it's easy to manage. That's how it works. Let's say you have user 1, user 2, user 3. This is allowed rule 1. All of them have role 1. Some of them also have role 2. Alright? And let's say this user left. This user is made user 1, this thing. Alright? All the operations, and we have to add R3. And a new user has come in, user 4. You want to add R1. You see what is happening? When users come in and go out, you have to keep attaching and removing the roles. Now that's a headache anywhere. Instead, what we do is we bring in a new thing in between. Instead of attaching the role directly to user, roles are already attached to groups. So G1 has all the roles attached to it. G2 has all the roles attached to it. Now, when a user comes in, all that you have to do is attach it to the group, and everything that is part of the group will be automatically added. Now, this also allows a user to be attached to multiple groups. Now, let's say you want To remove user 1 from group 1, you just have to do one operation, remove from group 2. If you are directly operating with roles, you have to remove 4 or 5. So it basically makes you managing this whole users groups roles easy. And it also separates roles from directly assigning to users. Now the question, can roles directly be assigned to users? Yes, you can. That's a bad practice. The good practice is assign roles to groups, put users into groups. Policy is a list of documents that have roles listed in it. Access, user access, authentication. Now the reason why I listed out here is you come across a different access once you are into cloud and everywhere. A common access we are all familiar with is username password. All right? You give a username and a password. Nowadays you are getting a laptop, I think, yeah, mobile. Earlier you used to have this thing, right? The pattern and the mask of Zorro kind of stuff. All right. Now you have this fingerprint. I think iPhone has it. When this thing has it. Now that's not username password. You see, that's biometric. Since authentication can be done in multiple ways. Agreed? We already know that stuff. All right. You use username password once upon a time. Then you started using biometric. Another way is also to provide a certificate, like an ID card. All right. Now, an ID card, when you say ID card, it has to be provided by a trusted authority. So, usually, what happens is, let's look at a laptop or a browser trying to connect to a server, or one server connecting to another server, server 1 connecting to server 2. All right. We will take SSH, the common example. When you do SSH, user at the rate remote IP, you are getting connected here. There is a SSH daemon here. What this guy is doing is asking you for password, isn't it? That's your common approach. So you gave a username. The SSHD said, okay, you are this user. Tell me the password. Now you tell the password, you are allowed to log in. That's one way. All right. Now let's look at the certificate way. Let's say server 2 trusts somebody, what is called a certificate authority. This guy says, anybody who this guy trusts, I also trust. Like, you met somebody new, all right, a stranger. The common approach we take is, I know your friend. If that person takes one of your friend's name, you trust. Okay. If my friend trusts this guy, I can trust. Means if somebody that you trust is referring somebody, you will allow that person to contact you or to interact with you. The same thing this server is doing. The server is saying, okay, CA is my friend. If somebody is referred by CA, I'll allow them to log into the server. A very simple trust kind of thing. So what happens here is server 1 trusts CA. These two are friends. So server 2 says, okay, if CA is sending somebody, I'll trust that guy. Now all that server 1 has to do is go to this guy and ask, okay, give me reference. I want to go to server 2. You both are friends, right? Introduce me to him. As we normally get introductions to our friends, right? So any stranger, what we do? If you want to introduce to be a stranger, you usually find a friend of the stranger. You go to that person, you ask, for a reference. That's it, right? So what happens here is server 1 goes to a CA, certificate authority, and asks for reference. Now that reference is usually a certificate. So CA, certificate authority, issues a certificate to server 1. What the certificate commonly will have? It says, okay, I know server 1, I checked everything. It seems okay, you can allow that server 1 to log in into anybody that I trust. Now this guy, after getting the certificate from CA, now goes to server 2. And how does it go? SSH-I with the abc.pem key. We'll talk about pem key. It's part of the certificate, all right? And now server 2. Now this guy is simply saying, instead of a password, now you have a certificate. So you still have to use the user, all right? So you're saying use the user. So SSH-I, so this goes with the certificate, a remote username. Now SSHD receives the request. He looks at the certificate. Earlier he was asking the password. Now he looks at the certificate. Okay, looks like my friend has referred you. Let me go and ask him. So he verifies the certificate. That's important. It's not like a blind belief. If you go, the server 1 goes to this guy and says, I got the certificate, he's not going to believe it outright. He's going to say, okay, let me check it. So server 2 takes the certificate, checks up with the CA. And if CA says, yeah, I gave him certificate, you can trust him, then is allowed to log in. So what happened now is, instead of a password, you are using a certificate. Now the reason why certificates are popular is, there is a trusted identity. At any point of time, you can revoke the certificate. Means CA can revoke the certificate at any point of time. Let's say right now, all right, today you got a certificate and you are able to log in. Today evening there was a security incident. All right, somebody logged into one of the servers. Now what CA will do? It will invalidate all the certificates. Which means all the certificates that this CA has issued are invalid. If server 2 comes to CA and produces a certificate, CA can tell, no, that certificate is invalid. Don't allow. Which means the login will fail. Now such control is not possible with passwords, because passwords are not stored centrally anywhere. And also the possibility of forgetting the password, reissuing the password, resetting the password, that's all headache. So certificates are more secure. Another problem is, most of the times the password is your company name 123, even for production. If you are in any project, the first thing you will try is your project name 123, company name 123, or the team lead name 123. Usually it works. Or 1 2 3 4 5 ASDFGH on keyboard. These are some 10 passwords, most commonly used passwords, and many of the times surprisingly they work. Alright, so the password is easy to crack. The brute force attack can be launched. Whereas certificates are difficult to crack and they can be managed centrally. So access is either username, password, or certificate. Nowadays, username passwords are slowly disappearing. So even on your laptop, you have biometrics now. So probably 2 or 3 years down the line, you will have everything biometric, your fingerprint kind of. All right. So that's your access, and in AWS, you will be creating users, you will be creating groups, you will be creating roles, you will create policy and attach the policy to resources, and you will also use username password to access your web console. You will also use certificate to access the resource. We will see all those things as part of your workshop. All right. Now this is your IAM. Now let's get back to network. Any questions here? Any questions in IAM? This is all you have to know. Especially you should have clarity on what a role is, what a policy is. Policy simply lists out roles. That's it.
The conditions, everything will be provided by us.
Yes, we have to decide who can access what. That's part of our job. But usually there are predefined templates. For example, if you have an administrator, there is a template what administrator can do. Or let's say there is a read only. There is a read only template. We just attach that template. It's not really that difficult. They're all predefined. If you are designing a security system, then it's really difficult. You have to decide who can do what. So it means you will be creating those templates. But in our case, in AWS or any of these things, the templates pre-exist. We just drag and drop the templates and we create the roles quickly. All right, let's get to network. Network, we'll try to understand using a diagram. VPC, IGW, NACL, subnets, ingress, egress. I'll explain to you using a diagram. That will be much easier. Not. వస్తుందా I'll post it to Slack, these three images. I'll be talking about these three images. రావట్లేదా All right, these three images. It's okay. Give it some time. Relax. We're talking about the first one. This is a three-tier architecture we're looking at. Let's see how the general structure is. This diagram actually, puts up everything in place. This is not the image. No? Full రావాలి కదా. సరిగా ఉండాలి. All right, let's see this thing. At the edge of everything, you have internet gateway. That's how you log into an AWS environment. It's just like when you say cloud, it's nothing new. Let's say there is a router. Behind that router, all the AWS servers are there. That's it. Just like our jump server and the servers behind it. Nothing really new, but it's more complicated than a simple jump server. So your general entry point to AWS cloud is the internet gateway, IGW usually called. Now the IGW is the edge of your virtual private cloud, VPC. The reason why it's called virtual private cloud, this is a private cloud. The reason is, if you have an EC2 instance or a physical server, let's say, a big physical server, on that physical server you have a lot of EC2 instances, all right? Now the physical server is common. Physical server is common. The EC2 instances are allocated to individual members or subscribers of AWS service, all right? This is called private cloud. A public cloud is usually accessible to everybody kind of thing. Right? Virtual, the reason why it's called virtual is you do not have access to physical machines. That's the reason it's called a virtual private cloud. So that's all the word signifies. What we are interested in is a VPC is a list of IPs. Let's say 10.0.0.1/16. Every VPC is associated with a list of IP addresses. You will see it at the very end. It's not there in this. Yeah. On the next image, if you say NACL versus security group, this one. You see this VPC here, 10.0.0.0/16. Now this is an IP range. It's called a CIDR range. Classless inter-domain routing, that's all. It's just an IP address, a list of IP address. Now this number here, all right, can range from, I think, 2 to 32, I think. The bigger the number, the less number of IPs you have in this range. So VPC has a CIDR range. That's what we are interested in. A CIDR or IP range. This is called CIDR range. This is for networking. You will have a lot of confusion here because of the networking thing. We will discuss all the things that we normally need. Beyond that, usually it gets more confusing. All right. Now, if you are interested in networking specifically, let me know. I have a bunch of videos. I'll give you all those videos. You can go through it. All right. Here we will restrict ourselves to what a general AWS admin requires. All right. So here, a VPC, when we say, we are saying you are getting a cloud with a bunch of IPs. We're saying all these IPs you can use in this private cloud that you are launching. Now IPs are usually associated with virtual machines. Anything else we can associate IPs with? Probably not. A virtual machine, not exactly a virtual machine, you associate it with a Ethernet card, a network card. That's where the IP is. A virtual machine can have any number of Ethernet cards. Alright? So normally when you launch an EC2 instance, you will need a IP. And where you are getting the IP from? It should be part of the CIDR range that you are creating. So the first thing that you normally create is a VPC after you log into your AWS account. And every VPC has a CIDR range associated with it. This is the number you will get. Now this range can be divided into smaller blocks. They are called subnets. So let's get back here. So your VPC, let's say, has a CIDR range of 10.0.0.0/16. Now you can actually check the number of IPs in that range using some tools. They are all available. CIDR range tool. We want to see how many IPs are there in that range. That's a range you are saying, right? Which means there is a beginning and there is an end number. So between these beginning and end, you have all the IPs. So you want to know how many IPs you have in that range. No internet? Boom 2. Password?
Incorrectly, 234.
No. ఏమైంది ప్రాబ్లమ్స్ అన్నీ ఈ క్లాస్లోనే వస్తాయి మనకి ఓకే ఇట్స్ కనెక్ట్ ఓకే I'm just googling for CIDR range tool. Alright, pick up anything. Usually you get a lot of tools. What we are trying to do is we give a range and we want to see the number of IPs available in that range. What's our range we are doing here? 10.0.0.0/16. Remember, the bigger the number, the less the IPs. It's inverse proportion. Alright? /16. Calculate. Now say this thing. First IP is 10.0.0.0. That's a network. Alright? The last IP is 10.0.255.255. How many total hosts you can put in this virtual private cloud? 65,536 IPs are available. Alright? Nobody will use it. Now if you see our network, we have a 22. Go to your laptop, command prompt, quickly. Run a IP config. This is 22. You will see 255.255.252.0. Now that is 22. Subnet. So we are in the network. I'm going to do it for this network.
Sir, IP config.
No 22. I just run IP config. You won't see 22 here. If it should be a Linux machine to see the 22. And the command prompt, IP config. That's a regular IP config.
It's not recognized as an internal or external.
Not that IP, not the Unix one. IP config, single word. Where is it? Yeah, you see this command? Yeah. IP config, it's a single word. Right? Now, this is the IP of this system, laptop. Now, this is a subnet mask. This subnet mask is /22. Alright? Now, I'm going to go back to the same tool here and see how many IPs are available in this network. So that is 192.168.1.1. 16/22. You see, 1024. This network can accommodate 1024 IPs. IPs, they are not virtual machines. A single virtual machine can have any number of IPs, right? Usually 2, 3, anything. All right, got basic idea? So what we have is a cider range associated with every VPC. The cider range simply tells you how many IPs you can put in this virtual private cloud. All right. Now this cloud or this network can be divided into subnets. Just the name itself says it's a subnet. Subnet means a part of your whole network, isn't it? All right. So you're going to take the same thing, part of it, you will allocate it to one subnet. Let's say you're doing 10.0.0.1/24. Now you can actually calculate this whole thing, but usually you change this thing, increase this number. That usually lands you in about 100 virtual machines. That's usually more than enough. Or you want precise numbers, you can always go to the tool, see the beginning IP and end of IP, and make sure they are not overlapping. Subnets cannot overlap. So what I am doing here is 10.0.0.1/24. This thing, I'll change this number 24. This usually gives me about 256 IPs. All right, you can check it in the tool. A 24 cider block gives 256. Because I am using the first one and the last one out, you will have about 254 IPs left out. All right, because this is 1 and this is 2, they don't overlap. So what you are essentially getting is 10.0.0.2.3, 4, 5, 6 like this until 256. 6, but 6 is usually broadcast, so usually you stop it at 254, 255. So you're getting 254 IPs in that one range. All right? So now the blunt way to remember is you take the main one, the VPC network, and change the last digit and always increase the number. Now if you reduce the number, your subnet is bigger than your main network. Let's say you put 15 here, you're essentially taking more number of IPs than your virtual machine. Now this is all, there is nothing like, these are not shortcuts or anything. There is a proper fundamental behind it, but the fastest way to calculate all these things without any issues is you change the last digit, increase the number to 24. Now remember, this usually gives you 250 virtual machines. The same thing here, I changed it to 2, 24. So you have two subnets inside this. The very name itself says subnets. All right. So a VPC has a cider range. A subnet also has a cider range. Subnets within a VPC should not overlap. All right. Now let's look at the next component. Internet gateway is at the very top. Here also you will get an IP. This is called a public IP. Whereas these are private IPs. All right. Now this is how you log in to your network. Now let's see the next one. After internet gateway, you have a router. What is the purpose of a router usually? That's it. It routes. It is simple. All right. Routing is basically sending here or here. It is done using a table called a routing table. So a router has routing tables. What the table ideally should say? If anybody is asking for this IP, send it to this network. That's it, right? Let's say there is an IP here and here. If a routing rule like this, destination, if the destination is 10.0.0.2, all right, anything in this network, all right, send it to one of these EC2 instances. You will see a routing table. Let me show you a routing table quickly. Don't have a routing table anywhere. What's the matter with this? Again, we have the problem. Yeah, it's not working. That's fine. So a routing table usually has a destination attached to it. Means it says if a request is coming for this destination, send it to this network. The same way, you will have another entry for this one. If a request is coming for one network, send it to this network, like that. All right. So that's your routing table. After the routing table, you have a NACL. So you have a NACL here and a NACL here. Every subnet is protected by a NACL. It's called NACL, Network Access Control List. ACL is a popular one. It's part of Unix access control list. This is for network specifically. So network access control list. It's called NACL. And NACL says who can enter, who cannot enter. All right. It has allow and deny both rules. You can say all IPs originating from outside can enter this one. Or you can say all IPs originating from outside should not enter this one. All right. Now, if you say enter, this becomes a public subnet, isn't it? Let's say a request is coming from IGW router and the NACL says allow, which means this subnet is accessible to the outside world. Now, this is where you will usually put your jump server. That's the server you want everybody to access, so that from this jump server, people can move to others, right? So this is public. Now, if something is public, what would be the other one? Private. Private subnet. So subnets are either public or private. Now, whether it's public or private is decided in your NACL. So NACL protects subnets. All right. Now, within a subnet, what do you have? You have virtual machines or your EC2 instances, right? Isn't it? These are all EC2 instances with IPs attached to it. The IP should be in that CIDR range of the subnet. You are deciding the CIDR range when you are deciding the subnet, right? So the EC2 instances here 10.0.0.2. Sorry guys, this is not 2. We will change not the first one, the second one. 1.0, 2.0. Sorry about that. So 1.0 will get 255, 2.0 will get 255. So the IPs of EC2s in this one will be 10.0.2.2, 10.0.2.3, 10.0.2.4, like that. Whereas in this one, 10.0.1.2, 10.0.1.3. So the last digit keeps changing. All right? Sorry about that. All right. So you have a subnet with all the IPs here. You have a private subnet, all the IPs here. Now, it's not necessary that you should have a public and you should have a private. You can have anything you want. All the subnets can be public or all the subnets can be private. Anything you want depending on the application requirement. So once you have here, now when a request comes inside a subnet, you have another level of protection, a security group. A security group allows or denies access to a particular EC2 instance. So a security group protects the EC2 instance. So around EC2, all EC2s, you have security group. Now this security group defines the ingress and egress. It tells what can come in, what can go. So let's see here. What is a VPC? A private cloud with a CIDR range associated with it. A CIDR range is nothing but a group of IPs. All right. An internet gateway is the entry point. Entry point with public IP. You connect through this public IP. All right. That's entry point to your virtual private cloud. Then a routing table here. Let me put some other words here. So you have a router and a routing table. What's a routing table? It's a table with destination entries. Each destination tells if the incoming request is heading to this destination, send it to particular subnet. So it simply lists out the routes. That's it. After a request passes through the routing table, it goes through a NACL. NACL protects the subnets. It has both allow and deny. Now this is called stateless. For some reason they call it stateless rule. Now as opposed to stateless, what should be the opposition? Opposite? Stateful, right? Now the subnet here also protects something, but this is stateful. So here the security groups are stateful, which means if you allow somebody in, you automatically allow that out also. Right? Like you remember, that's what's being stateful, right? You remember stuff. You allowed somebody in, right? So when you are allowing, you are checking whether that person is allowed or not. When that person walks out, do you still want to check? Can he walk out or not? Now that is your security group. If it is NACL, it will check. It does not remember you entering. NACL will not remember you entering. Means if it is allowing, it does not mean, if it is allowing you inside, it does not mean it is allowing you outside also. Alright, it's possible that it's only allowing you inside only. It is not allowing outside. So it cannot remember. That's why it's called stateless. Whereas security groups, they remember. If a request is coming in, a request can go out also. The response can go out also. They're called stateful. Now we are saying allow and deny here, right? Now for security groups, only allow. Means you can define only allow rules. Everything is denied by default. Means when you set up an EC2 instance and when you set up a security group, what's the default nature of security group? It protects everything, which means it's not going to allow anything at all. The default rule is deny, 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 deny. Don't allow anybody. That's the nature of security group. Means if you don't configure it at all, it means it's denying every request. Then you allow some types of requests into it. Now that way it's easy. Means the moment you set up a security group, your protection is ready. Then you decide who you want to allow in. Which means security groups, you will define only allow rules. You don't have to deny anything at all. Everything is denied. Alright? Now these are some of the points. You try to remember these points, you slowly understand it. Alright? And remembering these points is really important because otherwise you constantly keep getting complaints that I'm not able to access this, I'm not able to access that kind of thing. That's mainly because issues with your configuration of security groups and NACLs. This is a very common complaint you will see. I'm not able to access the EC2 instance. Somebody comes up and tells. So you basically configured your security group in a wrong way. Alright? The next thing, what do we have here? VPCs, internet gateways, routing, NACLs, ingress and egress. They're pretty simple. Within NACL, you have ingress and egress. Within security group also, you have ingress and egress. You will configure those things. Ingress will have kind of, what is the source, what is the port number, allow or deny, that kind of thing. That's all the rules are. When you configure these things, you get more clarity on it. But for now, try to get a big picture of what each component is. So a request lands on your internet gateway, moves to the routing table. If the routing table decides where it should go, it passes through a NACL. If the NACL allows, lands on a subnet. Once within the subnet, if the subnet allows to get into a specific EC2 instance or get into any other service that has an IP associated with it, it goes there. So you can have a request cut off at internet gateway itself, or there is no routing defined. That will also, it will drop the request. Router drops the request in that case. Then router allows, but it comes to NACL and NACL says no, you can't get in. So NACL denies it. Then NACL allows, it comes to security group. Security group says denied, you cannot allow. Which means you have 4 levels of passing through. Each of these levels you have to configure. So when you are setting up your environment, you will be given usually these things, EC2 these things. What you have to configure as an AWS administrator normally that you learn is everything else. Developers do not know this stuff. as a DevOps cloud administrator, you are responsible for managing all that, the access thing. So you define a VPC, you define an internet gateway, you attach these two things, then you define or check all your routing tables, then you check your NACLs and subnets, all right? Then you check your security groups, and then you see if a request is landing on required instance or not, all right? Now this is the general structure of any VPC, any account. This is a general structure, there is nothing more. The only difference you will see is what kind of services are there in this. All right, it could be an EC2 instance, or it could be a Lambda, or it could be a database, or it could be another service. Some of those services have IPs, some of those services do not have IPs. That's it. All right. Now, if there is an IP, this is the only way it can reach. All right, it has to come through this process. Now, these systems or these services which are inside a subnet, again, you can allocate security groups separately to each of these instances, and each multiple security groups can be there. That becomes a little more complex as we move more into a bigger architecture. You get clarity on it. Right now, what you have to understand is individual components. You create a VPC, you create a IGW, you create a routing table, you configure NACLs, you create subnets, you create security groups and configure them and assign them to your EC2 instances. All right. In our workshop, you're going to do a very simple architecture after you are done with the basic tasks. All right. Then you will get some clarity. All right. Now, next thing, let me quickly look through this thing. So that's your network, right? I will be working on network most of the times because anything you do should be part of a network, always. And next thing is storage. Here, let me quickly go through that thing. Don't worry about this VPC. If you could not get a hang of it, we will talk about it again and again. What is S3? All right. This is what type of storage it is? Images. It's basically called object storage. Now, these objects in AWS words are usually stored in buckets. All right, just like a folder, you can call it, right? So a bucket will have subfolder and then files like this. So you can have a D1 and then F1.png, F2.jpg, or F3.pdf. Any file is an object over there, all right? Now these are stored in buckets. Normally what happens is these bucket or these files can be versioned. So you can enable version 1, version 2, version 3, version 4. So all objects in the buckets can be versioned. So you can enable versioning. Now when you need versioning, let's say f1.png you have. If you upload f1-v1.png, are the same files or of different versions, or they are two different files? These two?
Same files are
Really? Just because I said -v1?
We're adding it here. Which is version.
Yeah, I said version. The name is f1-v1. That's actually a different version. But from an operating system angle, are these two different versions? Are these two same file with different version? Or they are two different files?
Different files.
They're two different files. Just because we change the name, operating system does not know that the two are same. If you want to enable versioning, or if you want AWS to track it, you have to upload it with the same name. Then it will realize, okay, it was uploaded yesterday, that's something different, and now you are uploading it different with different size and different other parameters. So this is different. So it stores both copies. The previous copy, it will call it anything you want, anything you want. So the versioning is not in different names. We are not the ones, if you do this thing, you are tracking versions. AWS is simply storing the image. It is not tracking anything. It does not know that these two files are same. You should upload it with the same name. If the properties are different, like the size and other metadata, it will automatically realize, okay, these two are different, which means should I keep track of them or should I not keep track of them? Then it will decide. Now, if you enable versioning, it will keep track of both of them. Means it will have copies of both. So version enabling is a feature available for S3. Then the next feature, very popular one that everybody talks is, now you have all these images, right? Let's say you are a photographer, all right? You are clicking a lot of photos. Every time anywhere you go, you are clicking. All right? You have a digital camera and you are clicking everything. How many photos you will take per day? 100,000 if you are a photographer. You have any photographer friends? They're crazy people usually. They keep clicking everything. Right? Probably 1,000 photos, let's say, on a normal day. Right now, let's say every day he goes out there and in the evening connects it to the laptop and uploads everything to an S3 bucket. After a month, he has 30,000 photos. Now, let's say he's a very good photographer. After a year, 12 multiplied by 30,000. You see the problem? Now, most of the photos, he wants it because he's a photographer, but they don't really are useful. But AWS is charging him really high. You are storing raw photos, high quality photos taken on a very high-end digital DSLR camera. And this guy says, okay, how can I save some money? This guy is costing me too much. Then AWS allows you lots of types of storage. What it says is, okay, you don't need these things, all right? If you are not opening any of these images for the next 30 days or 60 days, we have a very cheap storage called Glacier, where you can store everything. But the problem with one is, if you want to retrieve it, it's going to take you 5-6 hours. SQL says, okay, fine, I'm okay with it. So you can set up a policy or what we call life cycle policy. The life cycle of the object. You're saying, after 30 days, if I don't open the object, move it to Glacier. Now this is usually 90% cheaper, which means if this is 100 rupees per GB, this is 10 rupees. Now 100 rupees, 10 rupees, you won't realize it. 1 lakh versus 10K. Now you can feel it. 10K, you're okay, okay, fine. 1 lakh, no, not fine. Right? So what we have is, AWS or all the cloud providers will allow your object to move to other storages. Now what I've seen given you here is one extreme, very frequently accessed kind of objects to not at all accessed kind of thing. Now in between these two, there are 3 or 4 stages. By the way, the third image that I given you, it lists out the differences between security groups and NACLs. Try to understand these things. You don't have to remember, but it's important that you understand. And if you don't understand something, ask me again and again in the upcoming sessions. Malli problem. Because layout in the internet. అక్కడ ఎవరో కనెక్ట్ చేసి ఉంటారు రాంగ్ పోర్ట్ కనెక్ట్ చేసి ఈ ప్రాబ్లం వస్తుంది ఫ్రీక్వెంట్ డిస్కనెక్షన్. దట్స్ ఓకే, విల్ సార్ట్ ఇట్ అవుట్ లేటర్. Alright, just do this S3 bucket life cycle. You will see a lot of images. We'll pick up one of those images and we'll see all the life cycle stages. This is better. How many stages you have? 1, 2, 3, 4, 5, 6. These stages keep changing, so don't try to remember everything. You just have to have an outline. All right. Frequently accessed. All right. It's called standard. So you upload something, you keep on accessing it on a daily basis. You don't access it for at all. It's Glacier. All right. In between, infrequently accessed, single region, and couple of other things are there. S3 standard infrequent access, S3 intelligent tiering, one zone, Glacier, deep archive. Okay, let me list it off. Standard infrequent access, intelligent tiering. Nobody will ask you to remember these things, but they are logical. Then one zone, then Glacier. Nowadays they have introduced another one, deep Glacier. I'll pause this image. Alright, that's your image. So standard is frequently accessed. Infrequent access means you are not accessing so frequently. You can move it to infrequent access. This is. If you are accessing once in a while, once in a week or so, that image. Then intelligent tiering is automatic, means it will automatically move across these tiers depending on your uses. You don't have to really worry about it. This uses that machine learning, IA, all that stuff. All right. So it basically, depending on how frequent you are accessing, it moves your images into one or the other. Nowadays, if you're a regular user, you usually choose this intelligent tiering thing. It gives you an optimal billing. Then one zone. AWS is usually divided into regions. Now let's look at the world map. Who knows the world map? West, North America, South America, Europe, Africa, Middle East. We will put our country here. Better. China, Russia, Japan, Australia. Right? That should do. So world map. Right? Now AWS is spread across everywhere. So what they call is regions. So this is one region. This could be another region. This could be another region. When you logged in yesterday, at the top right corner, you will see a big list of regions. All right. The default region is North Virginia. All right, it's somewhere here, I think. We also have a region Mumbai. All right. Now, a region usually has availability zones, AGs they are called. So you could have in one region, you can have from 10, 20 availability zones. So if US has the maximum number of availability zones. Availability zone is kind of, Hyderabad is in availability zone now. There are 4 or 5 Amazon data centers coming. There in Vikarabad one, and then there is a Fab City, there is another one coming, all right? So an availability zone is usually a couple of cities together, all right? Now an availability zone has data centers. A data center 1, data center 2 spread across. Now, if you can imagine, I think the construction is underway, AWS data center, it's in, where is that? You go to Sri Salem Highway, there is a 200 feet road that's coming up on that road. Yeah, near to that, yes, somewhere near that. We went there once. TCS group is constructing it, all right? So an availability zone is composed of data centers. So you have data centers together composing an availability zone. Each availability zone is independent of other availability zone. Now the idea is these data centers are nearby. Like, around Hyderabad you have 3, 4 data centers. These 3, 4 data centers are connected with fiber optic cables, high speed fiber optic cables. And the data is replicated across these data centers. All right. Now another availability zone could be in Mumbai. All right. In Mumbai, around Mumbai, they'll put up some 3, 4 data centers. Again, all of them are connected. Now your data is replicated within a zone, within an availability zone, and across availability zones also. All right. That's how AWS guarantees that you have a 5 nines or 9 nines durability. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the percentage of durability. Durability means it's available. There is no chance that your data will be lost. The way they ensure is your data is stored in one data center within that same city or within that availability zone in another data center, also in other availability zones. Means if your data, let's say you are storing something in your Hyderabad availability zone, around Hyderabad 3, 4 data centers will have your file, and also another availability zone which is in Mumbai. In that there are about 3, 4 data centers. It will also have your files, which means your file is pretty much stored in about 10 locations. Now all these 10 locations data center going out is not really possible unless we have a nuclear war kind of. All right, if nuclear war is there, everybody goes out, so no problems. All right, so you have regions, then you have availability zones. Now what we have here is, if it is one zone, you are specifying, I don't want all this replication. You're saying one zone is more than enough. You are risking the losing, or probably you're not really worried about losing. What's the possibility of an availability zone losing is really low. You are saying 4 data centers around Hyderabad will shut down at a time. Very unlikely in my lifetime. That's okay. So you say only one zone. The reason is you want to reduce the cost. So you have less replication, less cost. Then Glacier, if you are using it very less and less, means you are not opening that file very frequently. Then there is a deep Glacier, means much infrequent. This deep Glacier, I think it takes 12 to 48 hours to retrieve a file. You put a request like service request, and it comes into your bucket after 12 to 48 hours. A Glacier is about 6 hours to 12 hours. One zone is immediate, but replication is not available. Intelligent tire, it keeps moving around. Infrequent access is, it takes about 10 minutes. Standard is immediate. So your S3 gives you facilities to decide how you want to store your data. And usually the storage is based on how frequently you access. Now you can set up this whole thing as a policy. So on a bucket, you will say all the objects in this bucket should be moved to infrequent access if they are not accessed for 30 days. or all the bucket, all the images in this bucket should be moved to deep Glacier after 6 months. Now these things are usually used by banks and all these things. Now, let's say you are applying for a loan. You got your loan. All your documents are in digital format. You're not going to retrieve that digital documents very frequently, probably for next 3-4 years until you repay that loan or something happens. So what they do, a loan sanctions for 30 days around, they are in standard, move them into deep Glacier. We don't really need them. They are required only for legal publications or legal requirements. Now, banks or other companies have some legal requirement like you have to store all the records for 7 years. All right. Now, which means all your bank account details, everything, your bank transaction details, everything will be stored for 7 years in deep Glacier. All right, like that. So S3 has a life cycle. Each S3 bucket can be associated with a life cycle policy. The policy you will decide where your data moves and when your data moves. Right? That's your S3. So S3 has two features. One is versioning, other one is life cycle. All right. Any questions here? It's simple. Once you do it, you get more clarity. Any questions?
Automatically the version కింద convert చేసుకుంటారు. So
If you enable versioning, yes. Let's say you enable versioning on a bucket, it automatically tracks all the things that you are putting into it, all updates. The file name is same. So yesterday you put a file name, today you are uploading the same file with the same name, but the data is different, means the size is different and some property is different. So it stores the previous version, it stores the next version also. Now you can decide how many versions you want to store. You just want 2 versions or you want 100 versions, that's something that you will decide. Depending on the number of versions you store, obviously you are storing copies, right? So the size of your bucket increases, your charges will increase accordingly. But it will simply track the version. Means you can say, give me the same file 10 days before, how it was.
ఇంకోటి స్టాండర్డ్ లో మనం ఒక డేటా కింద స్టోర్ చేసుకోవాలనుకుంటే అదే ఆటోమేటిక్ గా స్టెప్ బై స్టెప్ వెళ్ళిపోతా ఉంటుంది.
Yeah.
Some 3 months తర్వాత.
Yes, we'll set up the policy. Yes, that's it. It's automatic. We don't.
I mean, store అయితే ఉంటుంది. I mean,
that's what Amazon is saying. We don't know whether Amazon is lying or not. We just have to believe it. Unless something goes wrong. ఇది అక్కడ అన్ని దగ్గర జరుగుతుంది. ఏదో ప్రాబ్లం వచ్చే వరకు మనకు తెలియదు ఈ ప్రాబ్లం వస్తుందా. ఆ తర్వాత వీఆర్ సారీ అంటారు, గవర్నమెంట్ కూడా సారీ అని చెప్తారు. వీల్ మూవ్ ఆన్. ఏం చేస్తాం, ఏం చేయలేం. ప్రైవేట్ ఫైల్స్ ఎవరు పట్టించుకోరు, గవర్నమెంట్ ఫైల్స్ ఎవరు పట్టించుకోరు. ఎలా గవర్నమెంటే నువ్వు అని చెప్తే నో బడి కేర్స్. అంత వరి అవ్వదు, కొన్ని పోతాయి, ఏం పర్లేదు. 10th క్లాస్ సర్టిఫికేట్స్, ఇంటర్మీడియట్ సర్టిఫికేట్, డిగ్రీ సర్టిఫికేట్ చాలా మంది ఉన్నారు ఇక్కడ. డిగ్రీ సర్టిఫికేట్ ఏదంటే తెలుసు ఎక్కడ ఉన్నారు. ఓకే, ఎనీ క్వశ్చన్స్? Yeah.
Policy can directly give to deeply Glacier without going to the all.
Yeah, we don't have to go through the whole sequence. We can set up a policy that says after 30 days, directly move to deep Glacier. Banks will do that. We just talked about an example. After your loan is sanctioned and money is disbursed, all right, after they got their first payment, move everything directly to deep Glacier. Your account is already settled, so things will fall in place. The loan application document, they are not going to need it very infrequently. So they immediately, after 30 days, they directly move in here. All these things need not. It's not a sequence. You can jump in and out anywhere you want. All right. Today you have a AWS workshop and the documents are at a different location, guys. So everybody log into. Yeah, I think Vasu will give you those details. I'll give it to him. All right. Any questions in here? Zoom call starts.